So let's start. Thanks for being here. The topic of my talk is how to develop, run, and optimize Spring Boot applications on AWS Lambda. So before I start, I just would like to understand who is a Java developer here. Okay, that's good because I also had other situations that I even didn't know whether to continue or not. Who has experience with AWS Cloud? Okay, roughly a half, and has worked with serverless technologies like Lambda API Gateway, DynamoDB. Okay, very mixed round, but that's okay because it's not a talk about why serverless and basic concepts behind, especially Lambda and API Gateway. I will say at least some words so that you just feel that you understand at least the whole picture. So yeah, my name is Vadym, and I have these two passions, Java and serverless on AWS, especially. So I just investigate how to make Java performant on AWS Lambda. Yeah, you can get in touch with me via different channels. I'm quite active, posting a lot, and yeah. Yeah, it's not about the company, but we are completely on AWS since 4 years, and I started as a Java developer in the end of the last century, basically. So, but this topic is more my private research, how to make things work properly. So what's the motivation behind this talk? So the people are coming, which is very, very pleasant. um, so as you may be recognized from my t-shirt, I already spoke at this conference 3 years ago, and I explained basically the talk was about how to make Java performant alone without any frameworks on top. And I wrote a lot of articles about that, and 3 years ago there were not too many technologies to make Java performant on AWS Lambda. Performant, I mean startup times, other problems, cold starts, all that stuff. I will touch upon it. But yeah, the question I had received during one of the talks, yeah, it's pure Java, but we are completely working only with Spring everywhere. So can I make Spring be performant there? And yeah, I showed the numbers with pure Lambda with this startups time call starts, that's the same. And you could optimize them. Now we have even better technologies, or at least something to compare. And yeah, it was just, yeah, Spring Boot uses too much runtime annotation processing, reflection, dynamic class loading. So it will probably be, it will not work out on AWS Lambda itself. So the call starts will be so big that it will not be usable. It will impact performance. And for me, it was basically the motivation to investigate this in the last years. What technologies basically do we have to tackle this problem, and whether it's still a good solution to go with Spring Boot? So basically, this is how you would write Lambda function without any framework. So this is where you execute the business logic. And basically what I do here, I have the application, I will show you it later, just to create and retrieve the products. And you see I stored it in DynamoDB. Let's forget it for a second. And I need to implement request handler interface and write the handle request method. And basically the trigger is API gateway. So it comes from this API. I just retrieve the ID, product ID as a parameter, and ask DynamoDB. So basically, there is nothing wrong that you simply inject here product DAO with a Spring inject annotation, auto-wire annotation, depends on. Nothing wrong. I just wanted more to focus on other scenarios that might be more portable within AWS itself. With DynamoDB, you are probably locked anyway to the database. You can try something else. That's fine. You need to remeasure the stuff. But in this talk, I would like to focus more on the solutions that you say, okay, if it doesn't work on AWS Lambda as expected, I can go to containers. I can go to plain EC2 instances. So there will be investigation of more portable solution that you don't need to write or rewrite too much logic. Yeah, you will need to adjust probably dependency injection, dependency management, POM XML, infrastructure as code always looks different depending on where you deploy it on all cloud providers, but the business logic will be easier to adapt. So this is a very basic application. We have much more complex stuff at our work with 200 Lambda functions, and simply typed it out to 2. So we have API gateway just to receive the public API request, and we have create product Lambda function with the business logic to write to DynamoDB and get product by ID, basically just. So once again, I use DynamoDB here. This is NoSQL, completely serverless managed database. You could make it work with other approaches, but you need to remeasure. You have plenty of choices on AWS how to do it. You can use RDS, you can use Aurora serverless and newly introduced Aurora DSQL database from AWS, which is relational database, Postgres compatible with some other trade-offs. But it's possible if you say NoSQL database is not my world. It's just another complexity. I would like to stick with relational one. Then it's perfectly possible, but you will need to remeasure. Because I try to be as serverless as possible. That's why DynamoDB is the choice. This Aurora DSQL became generally available last month. So I need to investigate what would be the trade-offs. So what would be our agenda? We will investigate, first of all, what are the frameworks, and there are all open source frameworks to make this solution portable with Spring Boot. We will measure performance and see how we can optimize this performance, basically. And performance, I mean, especially startup times, which is the problem, and execution time, which is less the problem. So we will see here frameworks like AWS Serverless Java Container, AWS Lambda Web Adapter, Spring Boot Cloud Function, which is native Spring project, and it has adapters to different cloud environments, like AWS, for example. Docker, I will only mention, it has the worst cold starts, and you cannot do anything about it, but you just can package Docker containers on Lambda as well. So first of all, I will show you the common code for all approaches. So all these solutions will reuse this piece of code, and then we will dive into specifics. So first of all, you always have some kind of entry point to Spring Boot application, main class with this Spring Boot application annotation. I have this record product, basically simplify with ID, name, and price. And I have this repository where I store things into DynamoDB. Simply, you see here, put product. To create the product, I use AWS SDK to do this, and I have get product by ID. This is, if you are not familiar with DynamoDB, it might look a bit strange, and we will need then to dive deeper into this just to understand this. So basically, repository can be completely reused in those cases. Now let's come to the difference how we can do the things. So the first framework is AWS Serverless Java Container. By the way, I will share the links. You have here also links to my GitHub repository with the source code. So you can later simply just clone it and try the things out. Yeah, so there's complete examples, so you can just do this. So all the frameworks that I will show you, they are basically some kind of adapters. Because in AWS, you will need Lambda function, but if you would like to reuse the code, then all these frameworks adopt this to some Spring stuff. For example, AWS Serverless Java Container, which is open source framework maintained by AWS, they provide support that you can reuse struts, Spring Boot application. By the way, I dislike to ask how old you are, but who knows struts? Okay, then you probably will be around my age. I even work with struts 1. And didn't have a chance to work with struts 2. I just jumped into Spring. But basically, they support this. There are containers, different containers to support this. We will use, obviously, Spring Boot even 3. And what they do, they provide adapter logic just to minimize code changes. So they translate the incoming requests into the Jakarta EE servlet specification. And we will see what does it mean. So basically, what to do here is in POM XML, you need to import this AWS Serverless Java Container Spring Boot 3. Yeah, and that shows, yeah, you use exactly that container. You need to exclude Tomcat because you use managed API gateway. You don't need Tomcat because it packages another 4.5 megabytes, and you don't need to do it. And then there is a magic, of course, and if you use AWS serverless, there will be Lambda function, but you don't need to write it. What you need to write is pure REST controller. Yeah, so you basically reuse your REST controller. And this is something you see here, get product by ID request mapping, which kind of listens to product's ID. And I use DynamoDB DAO just auto-wired to write things and here, to read things and here create. So basically, you don't see any sign of AWS dependency here in the business logic. Yeah, you simply do the magic in POM XML and the things work. Of course, you need infrastructure as code to map. I use some framework which is called SAM, so I define here, we will always look into get product by ID function. I define that this API gateway request product/ID, and this is HTTP method get. And as you saw, it will be automatically mapped to this get product by ID because request mapping has the same properties. You see here, path is product/ID, and method is get. And then this kind of Lambda function will be mapped by Spring Boot container, serverless container framework to this controller method. And the same is true for create product, just the same stuff. But basically, if you define Lambda function, you need to give pure Lambda function code. So the function which basically implements this request handler method. And a serverless Java container framework provides you kind of this function out of the box. You need to simply copy this function. It comes with the package, and then this Lambda function will delegate it automatically to your controller. So basically, simply copy this one. You can write your own, but this is if you don't need too much modification, you can simply reuse one packaged for you, and it will simply deal as an adopter. So that's it. You basically, in the business logic, as you saw, that it's plain controller. Yeah, and that makes it portable. If you see, okay, it just doesn't work out, you can go to the containers or whatever it is. Yeah, just remove the dependency used as normal Spring Boot application. So we have AWS. That's it for that framework. Measurements I will show. We have AWS Lambda Web Adapter. That's another framework with another from another community of AWS. It's written in Rust. It's quick, and they not only support Java programming languages, they also support Express.js, ASP.NET, so all other stuff. Its package should be different. There is something like Java layer, where you simply just put some foreign application as a layer, but basically this type of thing supports not only HTTP requests, like via API gateway, you can use simple queue service as a trigger, even S3 as a trigger. I focus mainly on web application, REST application. That's why I don't need this on top functionality, but it gives you more, but it's more generic framework. Okay, I probably need to laugh. Okay, so in terms of the business logic code, you reused completely the same controller as in the first example. No changes, and yeah, no dependency to AWS. The first part of the infrastructure code is the same. The mapping between how you define Lambda function and the controller, REST controller Spring method remains the same, but once again, it's packaged differently. So you don't need to define Lambda function in this case. You define Lambda layer with this Lambda adapter, which is provided by AWS. They simply give you the string, you copy this, the last number is the version, so they sometimes change something, so you need to look what is the recent one. And instead of Lambda function, there is a bash script, basically, that you need to define, which always look more or less. You can copy this, and this class is the class annotated with Spring Boot application annotation, which I showed you in the common logic. This is main entry point. So there is no Lambda function, but there is kind of the script that you define. And also, just once again, really not too much dependency, and you are good to go. So the third one, who knows Spring Cloud Function as a framework, which is maintained by Spring or by Broadcom, whoever it is. Yeah. So the goal of this framework itself, they expose functions in terms of Java 8 functions, functional interface, to everything you would like. You can expose it as a JMS message, but you can expose it as a Lambda function, AWS. You can even expose it normal functional interface with the apply method also as an Azure function, which is not the topic for today, but they give you even some abstractions to easily migrate maybe the business logic itself out of AWS somewhere else. Yeah, and it fits very well into this model, and basically it's all the same. This is adapter. Basically, there is always API gateway. There is some Lambda function that you probably don't write, and then it will be translated all the way down to HTTP server request. Then it will invoke Spring Dispatcher servlet. Then your usual Spring Boot logic will kick in, and then the response will flow back. So basically, all these frameworks are some kind of adapters that work maybe a bit differently and for different use cases, but for the same goal. What you need to do in dependency management, declare the Spring Cloud Function adapter AWS, yeah, to wire your function as a AWS. Lambda function, and you need to have dependencies to Spring Cloud Function Web because it's a web request. Once again, you can exclude Tomcat because you have API gateway, so that you don't have too much dependency. And the infrastructure as code looks like this. So you basically need to define more. You need to define this generic Lambda function, which comes with the dependency. So this is, you don't need to write it. It's just part of this Spring Cloud function AWS, which will do this proxy or adapter logic. You need to define main class. This is with the Spring Boot annotation. And then you need to map this Lambda function to the class which implements function interface. So how we write this logic, we implement function, Java 8 function interface with the apply method. Here is this, unfortunately, because my input is API gateway input, I have a dependency to AWS library. I cannot inject it. It's not a controller that I can simply, I'm only interested in this path parameter. Basically, I need to do this get path parameters, but there is no way in this framework to inject that and get rid of this AWS logic. So this is a bit of disadvantage here. But basically, now you need to map map those things, infrastructure as code, to this class that I showed you, and it works like by defining cloud function definition parameter. And in this case, by default convention, this is get product by ID handler, because the bin name in Spring of the class is the class name and the first letter is the lower letter. So this is how that maps together, and that's why this Lambda function knows, okay, this is the bin name, and I need to find the class with that bin name to invoke kind of the business logic. And this maps together. So once again, here, a bit different trade-off. I don't have any controllers. I have the class which implements function interface, and I have a bit of dependency to AWS, which doesn't make it easy, for example, to go to Azure. Yeah, I will need to rewrite a bit of business logic. So you can, all three applications that I showed you, you can also package as a Docker and deploy it on Lambda. You can deploy as a container image. I will not show you the examples because the performance is the worst one, and there are no solutions just to improve that, but I will show you the numbers. So once again, now let's do some of measurements without any optimizations. Time is okay. So once again, maybe not everybody knows how Lambda, AWS Lambda works, where you execute the business logic. This is function as a code. So basically, it's different to the servers as a code, platform as a code. So the environment can only execute one request at a time, and then the environment put back into the pool of warm environments, a bit similar to how gDPC connection will be put back to the data source pool. Yeah, so you cannot execute, you cannot scale like you scale Tomcat applications. So just many requests, and then I need to scale horizontally if the one server cannot execute. So one environment, it's a quick environment, it needs to execute, they can only execute one request at a time, but you can have many environments kind of in parallel. And this is kind of, for those who doesn't know, the cold start time or startup of the application, which are synonyms in that case, happens if you don't have the warm environment all ready to execute your business logic. It needs to be started, and it has costs. We will look into this. When this happens, for example, you change the code of your Lambda function or deploy it for the first time. So the containers are not there. Yeah. If you had the older version, it will be destroyed because you need the container with the newer version. So the first invocation will be a cold start because the container need to go up. Or you have 5 warm containers and you have now 10 requests in the same time. 5 can be reused, 5 are not there. They need to be started just to serve the request. You cannot wait until those 5 will return, then the latency will explode. So the containers need to go. So these are kind of the cold starts, and you will see the measurements. So what happens in case of cold start? In Lambda, you can select your programming language, and we will select, of course, Java 21. It's the last long-term version. Lambda only supports managed long-term programming languages, so I hope there will be 25 then later this year. So what happens? So there is, of course, this environment. This is the whole execution environment, and you can think of this like maybe container, yeah, and you need orchestrating this container. And AWS has its own solution called Firecracker VM, which starts this very small, isolated, secure environment to start this stuff. We selected Java as a programming language. Of course, JVM needs to be started. It takes time. Your Lambda function code needs to be downloaded. Yeah? If I deploy application, I upload it to S3, Your code needs to be downloaded. And then the class loading needs to happen in case you have Spring Boot. Of course, static initializer block of your function, Lambda function, auto controller needs to be loaded. You have runtime dependency injection. So the things that classes will be loaded. So all the stuff, the dynamics that happens for the first time, this is a cold start. So basically you see here, download your code, start new execution environment, kind of firecracker VM with Java, and do all the static initializer block is basically considered as a cold start. And if you have the warm environment, then only the Lambda function controller method or this handle request method will be executed. So in case you don't have the warm environment, all four steps will be even executed. And the first three basically are expensive ones, and we will look into the metrics. So once again, I showed you that application. I did the measurements with 3.4 Spring Boot. You can use 3.5, I think now. I gave Lambda 1 gigabyte of memory, which is good trade-off. As a starting point, we will look into this, and I did the stress test for 1 hour. Basically starting requests, multiple hundreds requests in parallel. Then I stopped this, so then the environments will be gone, and then it will start again, and all the stuff just to see how many cold starts I will have, and then to measure all the stats. And it took 1 hour just to measure. So the first of all, you see within this hour, I had, with my pattern of invocation, yours might be different, 100,000 warm starts. And only approximately 100 of them were cold starts. So what does it mean? The cold starts happen rarely. Yeah, in this case, it's 0.1% of invocation. Your pattern might be, if you have spiky application, I saw the cold starts of 2% and so. Yeah, so it might happen, especially if you have the page with many Lambda function invocations. One of them can be cold start, and it will slow down the whole chain. It might happen. Yeah, it's very simple, fairly simple application. Yours will be different. Yeah, so this is the first one. It doesn't happen too frequently, and we will look into the measurements. So once again, I will show you measurements. If you see this cold picture, that means cold start or startup time, and the warm start is the execution of the business logic, basically. So let's start with the cold start without any optimization. You see here approaches, AWS serverless Java container, AWS Lambda web adapter, Spring Cloud function with AWS adapter, on Docker. And you see here percentiles. I always focus on this yellow one, it's P90, because in 90% of the cases I have those results or less. And it is, it's just a good metrics. You see the results are in milliseconds. So basically you see cold starts here in P90, 7 seconds, with the Lambda web adapter, nearly 5 seconds, with Spring Cloud function, also 5 seconds, quite a big cold starts without any optimizations. So if you have these cold starts in 1% of the cases, you probably know the Amazon study, how many people leave the application if it isn't loaded within 1 or 2 seconds. And here you have 5, 7 seconds. So this is one of the things that might be scary. This is for completeness. I would like to show you there the same application with the products, but without usage of Spring. This is a pure Java function, which I showed you previously. I only talked to DynamoDB that you see that P90 is 3.2 seconds. And you have here 5, 7. This is that Spring Boot, this dynamics adds to the cold start. So this is general problem with Java and JVM. You will have this cold starts. We will see how to optimize them, but Spring Boot doubles them, basically. And this was the motivation. We cannot use Spring Boot. Let's see. These are the warm starts. So the execution, if you have the warm container, only the business logic will be executed. Basically, you see P99, 20 milliseconds. Java is a very fast programming language. It's not a problem. Without Spring Boot, with a poor Java function, without Spring Boot, it's comparable. So the warm starts, the normal path, if you don't have the cold start, you basically can ignore it. There are no issues. Let's jump over it. So now you saw this cold starts, and sometimes people seeing them leave the room and say 7 seconds, I cannot convince my boss, it's not possible. Let's look into how to optimize them, because there are ways, otherwise will be probably not interesting to talk. I will be talking about AWS Snap Start. It's AWS technology in GraalVM native image. So what is AWS Snap Start? Obviously, it's AWS own technology released 2.5 years ago to improve startup performance. for latency sensitive application. Startup performance, cold starts, startup times, the same. And it's fully managed, and will show you what does it mean. So basically you decide per Lambda function, it's your decision, would you like to have snap start or not? That's basically activation. You go to configuration and say yes, snap start yes, or default is no. Currently, snap start is also not only supported for Java environments, but since end of the last year also for Python, that you can load your LLMs with that, and also .NET. But previously 2 years, it was only Java technology. It's only available for this managed runtime, so it's not available for Docker, because Docker is not Java runtime, it's container runtime. That's why I will not dive too deep into the Docker stuff, because you cannot apply snap start and you cannot optimize Docker cold starts. You will leave with 5 seconds. And if you will deploy GraalVM native image, you also cannot apply snap start. So basically, snap starts is a technology for this poor Java frameworks. So what is snap start? Basically, we saw that the environment is Firecracker micro VM in case of Lambda. It allows you to create and store a snapshot of this whole environment and then resume the snapshot. Yeah? And of course, the logic is here that the resume will be quicker than the cold start. Otherwise, it doesn't make any sense. Yeah? It should bring you something. Then the question is how to create the snapshot. And if you select snap start for your Lambda function and you deploy your application after this, AWS does additional steps only when snap start is activated. Then they start. Normally, you simply only deploy your application, nothing happens. But in case of snap start, they will start the environment, load JVM, load your Lambda function, and go through all steps, kind of the cold start, and then make snapshot of the micro VM, including JVM. Store the snapshot, and during the normal invocation, the snapshot will be restored and resumed. Basically, they added the step during the deployment because you cannot manage otherwise. Yeah? And snapstart that's why I manage, because they manage snapshots for you. They secure that, they place it in the 3 availability zones. This is all done for you. You don't need to take care of it. You don't need even the infrastructure for this. You deploy on AWS side and they take the snapshot. They run the additional environment. Maybe if you heard, who has heard about Creo crack and crack technologies? Are there any people? Okay. These are related. They come from Azure for the same purpose. I will not dive deep. These are similar stuff, and AWS reuses certain things, but there are differences. Firecracker micro VM saves the whole running operating system, and for example, Creo, which is Linux technology, snapshots a single process. But once again, AWS, they have control over the technology Firecracker VM, and then do the stuff. So basically, there are advantages, disadvantages, but the AWS just solved it by completely snapshotting the stuff. It's not the whole story. It's very easy. You simply say, I would like to have snapshot, and we will see the result only by doing checkpoint. You can do even more. This technology, you can apply priming on top of snapstart. What's priming? The priming is the way, so the idea of priming is to put as much as possible into the snapshot, so that after restore, the things are already there. Yeah? And Java is, for example, loads the classes lazily. For example, there will be only things loaded that are directly accessible from the static initializer block. Yeah? If I talk to DynamoDB during the worm execution, the classes will not be loaded by default because I don't access them. I first need one request, and then the things will be executed and loaded. It's lazy loading. And we can pre-initialize stuff. This requires a knowledge of the things. For example, DynamoDB is HTTP-based database. I talk to DynamoDB via HTTP behind the scenes. And this involves instantiating of HTTP client. Default one is Apache, and doing marshal and unmarshal operations because I store JSON in DynamoDB. And I have Java classes. I need to marshal or unmarshal, depending whether I read and write. And if you instantiate JSON marshaller, for example, you will write in your code new object mapper. This is how you instantiate JSON marshaller. And look into the time, the first instantiation is 300 milliseconds. It involves a lot of logic to instantiate. There are a lot of singletons behind the scene. If you do the next invocation, or next instantiation, that will be only 1 millisecond. because lots of logic. And this stuff is happening one time, and there is kind of, it's good stuff just to preload the stuff so that it's a part of the snapshot. The question is how to do it. I showed you this diagram previously, and there are hooks, optionally hooks. Before creating the snapshot, you can execute pre-snapshot hook and add some logic so that it will be a part of the snapshot. And optionally, you have post-restore, after restore hooks. For example, to restore some connections. I don't use it, but basically, you can do that. So the first idea, I would like to prime the whole DynamoDB request. So once again, I have in my DAO method get product by ID, for example. This is AWS code. Just I instantiate DynamoDB client, and I put the item into DynamoDB. By default, once again, it's HTTP, Apache client will be instantiated, and when I talk to DynamoDB, Jackson Marshall will be instantiated. So the idea is I would like to preload this stuff, and bunch of classes will be loaded. I would like to fake the call to this get product by ID DAO method. How to do this? Once again, these API hooks, I need to implement resource interface. This comes from this hooks API. And then I need to register this class as a hook, simply copy this line, and the magic happens here. I have two methods, before a checkpoint, before snapshot, and after restore. And the before checkpoint method, I simply fake the execution and say, I would like to load the product by ID 0. I'm not even interested whether the product is in the database. It's not my point. I would like to instantiate Apache HTTP client. I would like to instantiate Jackson Marshall, and it will happen. And I would like to load a bunch of the classes down the road that are involved in this invocation. And by doing this, it will be executed before snapshot is taken. This will be part of the snapshot. And even if it's HTTP connection, it survives the restore phase. You don't need to write any logic. AWS patch the SDKs, they patch a lot of stuff. You have the working connection after the restore. I even tested this on JDBC connection, and if it survives that, which is the magic itself. So you don't need to write the logic, so the connection is not there, restore. It works out of the box, a lot of magic involved, and very stable. There is one more priming technique. It involves much, so this code is very simple. Nevertheless, I have get product method in my DAO, so I just, a bit of logic. I can prime more. I don't personally recommend you to do this. I would like simply to show you it's possible using these frameworks to prime even much more as only DynamoDB. I basically can prime, how just to say, the whole execution, because behind the scenes, there is a Lambda function managed by framework like serverless Java container and Spring Boot function. And there is kind of the controller method that we have written. I wanted to prime the whole chain, like the request goes through API gateway to this Lambda function, which the frameworks basically uses as a proxy to the controller method. So it works like this. I just need to fake the JSON, which API gateway sends to Lambda. Yeah, I basically talk to API gateway by sending a huge JSON. You see here path, HTTP method. This will be put as a JSON. And then if I write the pure Lambda function, this JSON, in case of API gateway trigger, will be marshaled to this object, API gateway proxy request. And I just wanted to try out how can I prime that stuff, and it's possible. It requires a lot of logic to write, but simply just to show you that it's very difficult even to explain. But for example, for serverless Java container, I can instantiate this very heavily readable class, which comes with a framework, which name is handler. And then with that logic, I basically programmatically create this API gateway event. You see here method get, products null. Unfortunately, I need to pass all those variables, otherwise I will have 9 pointers. I can leave with less. It's a lot of boilerplate dummy stuff, but with this AWS proxy request object, I basically create this stuff. And with this before checkout method, I can proxy this. With that, I will create this AWS proxy request, and this handler that I created, which is provided by the framework, I can proxy this. So with that, I will proxy basically the whole chain, which I would say I would send as API gateway request that will go through this handler, Lambda function, which frameworks uses as adopter, and then brings that request to the controller method, which will be invoked. I know it's a bit difficult to understand. It involves a bit of code. I just wanted to, I call it API Gateway Request priming, but it's kind of possible. The same is with Spring Cloud Function. I will jump over this. They have different abstractions, but basically the same. I use function invoker API from Spring Cloud Function and basically proxy the same stuff. And then it just goes to Spring Boot function method. But let's see the results. I only show you P90, and this is, you see, cold starts P90. And you see here, this one is without snap start. I showed you that previously, the 7 seconds, all that stuff, P90. The green one is with snap start, but no priming. So simply checkbox, I would like to have snap start. The yellow one is step start with DynamoDB priming, where I simply call DynamoDB, and this one is with a full priming kind of the whole API gateway chain. So first of all, you see the red ones quite big without snap start. By activating snap start, I can cut the cold starts by 50%. So I am at 2 seconds without writing any business logic. Snap start check. It goes to the P90 2 seconds. With DynamoDB priming, which is very simple to write, I am already, depending on the framework, I can be 1.5 seconds of the cold start. And with this advanced priming with a lot of logic, I can go sometimes even below 1 second. But it requires a lot of business logic. That's why I say you maybe just be cautious without it. Check if you can do this, because you need to maintain the logic. But basically, you can bring down that to 1 second, a bit above, from 7 and 5 seconds. And this might be acceptable. Once again, warm start wasn't the problem, and it's not the technology to reduce it. So once again, AWS releases a snap start priming guide where you can look what can be primed, because it requires a knowledge. If you have the application like you write down string hello world, there is nothing to prime here. There is nothing that you can save by putting something into the logic to execute before the snapshot, or you do some calculator options. But sometimes if you have some invocations, it's worth faking them in this before checkpoint just to load the bunch of classes. It will help you, because they will be quickly there after the restore. AWS also released AWS Lambda profiler extension for Java, which is based on the asynchronous profiler, which is open source project. You can attach this and see the whole invocation chain, and it might give you ideas what to prime in your particular application, because you see the invocation stacks here, and you see, okay, this is executed, maybe I can prime it. I can put it into the prime logic and see, will it be helpful or not? I could prime a lot additionally without Spring Boot with that, and very good thing. Okay, I showed you the whole cold starts for the whole 100 cold starts, so the numbers for the whole 100 cold starts. There is one more thing here to know. This cache, low-tiered cache, gives you, so the first cold starts with the snap start are always slow because of the dynamics, how this tiered cache works, where the snapshot is saved. It simply caches the bits of your function, or the snapshot bits, and then with subsequent cold starts, the bits are already there, and that's why the restore is quicker. I wrote about it, but basically I can recommend you to watch the talk by Mike Danilov, which he gave last year on the KubeCon. He explained how Lambda works, how they implemented snap start, and how this cache works, because it's a real magic. Why I'm telling you, once again, I showed you only all 100 cold starts and values. I would like to show you the cold starts if I strip the first 30 cold starts and only show you the last 70. Yeah, and here are the results. You see here AWS serverless Java container with all 100 cold starts. Here are the last 70, and for all other frameworks the same. So you see that, yeah, if I strip the first 30, the cold starts for the last 70 was here even 700 milliseconds. For quite extensive priming, but you can look into the green ones, 1 second. Why is it important? The thing is, it depends how frequently you deploy your Lambda function. Let's imagine you redeploy it 1 time per week. Then within this week, you will be having maybe 10,000 cold starts. The first 30 are nothing here, yes? And the first are slow until the cache is filled. Yeah, so basically you need to look further. Yeah, so the first one will be maybe slower call starts, but then the rest 9,000 will be quicker. And so simply don't stop by measuring the first call starts. This cache is kind of, I don't have too much time, but it's just a magic. Yeah, and it gives you, on the long run, you have that. Basically, you can experiment with other things. Yeah, you can select other hardware architecture for Lambda. You can select different Java compilation option and memory setting by giving less memory and more memory just to see what is the performance and maybe also pricing characteristic. You can set other HTTP client. Default one is Apache, but you can set also URL connection, and AWS provided the native one, AWS CRT. They have different trade-offs, but you can experiment and put the call starts even down with different trade-offs. Some words about pricing. For Java, it's Snap Start is currently for free, but as the AWS released that for Python and Net, they provided pricing out of the box. So I would expect that for Java, they will change to that price as well, because everybody who uses Java on Lambda simply turned Snap Start on for all functions, on all environments, and AWS pays for cache and pays for restore time, and this is misuse. So they corrected this ideally for Python from the beginning, and they say the pricing doesn't apply, but you see the cache time will be priced and restore time will be priced. But as far as I know, it doesn't contribute too much also on the invoice, but it's additional pricing currently for free. So there are certain limitations. The most important or things to consider, taking snapshot, it takes between 2 and 2.5 minutes of time to take the snapshot, to secure it and store it in different availability zones, and this happens during the first deployment. If you deploy multiple Lambdas in parallel, the snapshot will be taken in parallel. It doesn't have a problem, but between 2.5 minutes you will have. That's the basic thing, and the snapshot is currently deleted after 14 days. So if you have Lambda function which are not invoked for 14 days, like on staging, you will get an error after 14 days. And then the snapshot starts again, creation starts. It will take 2.5 minutes and you will receive an error. So this is for frequently created functions. I will assume if the Java will receive this pricing, then no snapshot will be deleted. You will be simply paying for the storage. That will be, and you will need to take, but I don't suggest you to use that on staging. Once again, everybody knows what is GraalVM. I have not too much time. The same technology to reduce call starts and memory footprint. You can deploy these native images on AWS as well. You can look now. Spring Boot natively supports GraalVM now, but you need to use a Spring Boot ahead of time processing to process all those annotations during the compile time, because native image doesn't like dynamics. Yeah, you cannot invoke stuff simply dynamically. Simply copy the stuff. There are plenty of the same examples in the internet. Basically, you need to put this plugin, Spring Boot Maven plugin, and execute process RET task. Yeah, just copy the things from the internet, and then RET processing will be taken over. And there are plugins to execute to create native image directly. You need to pay attention to the dynamics. Once again, if you have classes that will be loaded dynamically, you need to put them onto those annotations, register, reflection for binding. I dislike these long names from Spring, but I cannot do this. But there is no way. There are certain classes like your entities that will be loaded dynamically. You need to annotate them, otherwise you will run into problems. Now let's see, the call starts with GraalVM native image. I use 23, you can use 24 now. You see here P90, 900 milliseconds. So comparable with certain priming techniques with Snap Start. And yeah, if you put it now, you have these 3 frameworks that we learned with a bunch of priming techniques. With Snap Start, you cannot do Snap Start with GraalVM. Once again, you see basically the comparable results with simple primings. Depending on the framework, with simple DynamoDB priming, you can put the call starts even more down as with GraalVM native image. But you need to test it for your application. But the results that I saw, they were quite close. Yeah, this is once again the comparison GraalVM with serverless Java container, and this is GraalVM 23 without Spring Framework. So you see, without Spring Framework, 600 milliseconds with Spring Boot framework, 900 milliseconds even with a GraalVM. So Spring Boot adds on cold starts anywhere. Yeah, this is basically the message. But what the good thing with GraalVM is you can give less memory than 1 gigabyte, and you can give 768 and have quite a stable cold starts. They will be a bit higher, but not 25% higher. So you can balance the costs with that as well. This is basically the stuff. So conclusion, GraalVM is powerful without any doubts. You need to do certain things. For example, AWS only supports Linux native images. It's not the problem. Build time is a factor. It cost me 3 minutes to build on my machine GraalVM native image, comparable to 2.5 minutes snap start deployment time. And CI/CD is on your shoulders in case of GraalVM. You need to build those images. It requires 10 gigabytes to build these images, and this is your CI/CD. You can use managed CI/CD, but this is your costs. Yeah, that's a cost factor. That's why I like Snapstart. It's managed. Yeah, I don't need to manage the infrastructure for creating snapshots. Once again, GraalVM releases which libraries are GraalVM battle saved, yeah, which are tested, that you don't have some runtime effects. I wrote the article series to show all this example in depth, so you can look into this. I now finished the article series to use Quarkus 3 instead of Spring Boot. Basically, less cold starts, but not everybody uses it. And yes, word of caution, remeasure the stuff. Yeah, AWS patches their managed Java runtime. That may be differences. You now have Spring Boot 3.5, or you can use Spring Boot 4 with other minor version. AWS improves Snapstart. GraalVM has 24 released, and all the stuff. So remeasure the stuff that I showed you. You can use my examples, but I think the direction will be the same. What I noticed, I also measured that with 3.2 Spring Boot. And after 3.4 was released, all artifacts became 10% bigger. And the bigger the artifact, the bigger is the cold start. The artifact needs to be downloaded, more classes needs to be loaded. So unfortunately, this is the thing that happens. Yeah, the suggestion is I always start with Snapstart because it's managed, and I see if it's enough for me, I use Snapstart. If I can prime and prime heavily, I use that. But sometimes if you really need the last millisecond of performance and you cannot prime too much, go for GraalVM native image. Nothing wrong with that. You will need to run just to pay attention to those reflection stuff that I showed you, but they are both valid technologies. And now we will all look into what happens with the project Laden, because it's official Oracle project just aimed to improve the startup time and peak time performance. But AWS needs to adopt it to make it managed like they did Snapstart, because I don't know how to use. They are all technologies based on some class data sharing and some snapshots, and we need a mechanism on the cloud to create those snapshots automatically and managed by cloud provider. So they will need to provide similar stuff. That's basically it. I know that there might be complicated stuff that I showed you, but if you have time, go through that. You can just see. So the message is you can indeed use Spring Boot, and you can have cold start 700, 800 milliseconds, which is acceptable also with a Spring Boot. Yeah, using pure Java, you will have probably 100-200 milliseconds less. But if you are productive with Spring, nothing is against using that, yeah, with optimizations. That's the message. I have 100 seconds for the questions, but I'm here also after the talk. Thank you very much. Are there any questions? Everybody is scared by complexity of Snapstart and GraalVM reflection.
Yes, unfortunately, I wasn't able to, because I'm using Lambda, play with the cloud, AWS. And no, I confirm the limitation that if you connect EFS,
yeah, it doesn't work. But yeah, there is no solution currently. Yeah. But we use S3, but once again, yeah, there are limitations you need just to look. If you use NFS-based system, then only GraalVM works. So there are nuances here also, yeah. So I will be thrown out of the stage now. Yeah, thank you very much.